So today we're going to do some more exponential growth and decay. These are similar to the ones that we did last class on finding the time value t in our calculator. So the first one here says you save up some money and deposit $500 into a savings account that gains 2.5% interest each year. Assuming you don't make any deposits or withdrawals, so we're just letting this money sit in the account, we're not doing anything with it at all. In how many years will you have $600 in the account? So first I have to decide, is this growth or decay? It's earning interest, which means the amount in the account is going to get bigger. So this is going to be growth. And our formula for that will be y equals a, our starting value, times 1 plus r, the rate, because it's growth, all raised to the value of t. So our starting value A is going to be the amount of money we're starting with. That's $500. And then our rate is 2.5%. But if we turn that into a decimal, move the decimal twice to the left, that's 0.025. So now if I put these into the equation here, I get y equals 500 times 1 plus 0.025, all of this raised to the t. And again, you can simplify what's inside the parentheses if you want, but it is not required. You get the same thing either way. It's really personal preference if you want to or not. So we have our equation here, and we are trying to find when this is equal to $600. So instead of y, I'm going to put my $600 because that's what we are trying to find. So now I'm going to go over to my calculator here. I'm going to put 600 in one of my y equals and our equation 500 times 1.025 raised to t, or x, our variable, in the other y equals. So I'm going to clear out what I have. So we're looking for 600, and then in the other one, 500 times 1.025. All of this raised to the x. We're using x just because that's our variable in the calculator. There's not really a way to type in a t. So now I'm going to look at my table, and I'm trying to find when I have at least $600. So I'm looking at all these y values and looking to see how long it'll take until I have at least 600. So after 5 years, I have 565. 6 years, 580 almost. So it looks like after 8 years, I have $609. So it's going to take 8 years. We have $609.20 in the account. All right, moving on to the second one. It says you take out a student loan for $10,000 with a yearly interest rate of 6.8%. If you don't make any payments on the loan, how long will it take for your loan to become $13,000? And if you're curious, I picked this percent based on my fiance's student loans. He has some that are only at like 2% interest, but then he has some that are around 12% interest. So I kind of just went with the middle, the average percent. So, and also typically when you're in college, you're not required to make payments as long as you're still in school. It's once you graduate that you're required to start making payments. So that's why we're just seeing how long it'll take. That's why, and also why I put if you don't make any payments. You can make payments while you're in school, but typically it's not required. Every loan is different though. So just if you take out a loan for college, make sure you know the rules on your loan. So same thing here. This is going to be growth because the amount we owe is getting bigger. if we're not making payments on it. So we're using y equals a times 1 plus r, all of that raised to the t. And our a value is what our loan is starting at. That's $10,000. And then our rate r is 6.8%, but we have to make this into a decimal in order to plug it into the equation. So that'll be 0.068. And now we can plug this in. So we get y equals 10,000 times 1 plus 0.068, all to the t. So remember, if you want to simplify the parentheses, you can. I will, just because then I think it's easier to type into the calculator, but again, you don't have to. It's also pretty easy to simplify. So remember, if you're trying to figure out what the amount is after t years, so I say like how much is on the loan after 6 years, then you would plug in 6 for t. But we are trying to figure out the money, the amount of time. We're trying to figure out t. So I need to set this equal to 13,000 because we're trying to figure out the t value when this equals 13,000. How much time until it's 13,000? So I'm going to go back to y equals, clear out what I have. So I'm going to put 13,000 in the first one, and then my equation, 10,000 times 1.068, all of that raised to the x. Oh, delete. Make it an exponent there. All right, so looking at the table, so I've got my 13,000, and I'm looking. So at my starting value after 0 years, I'm at 10,000. After 1 year, it's at $10,680. Let's see. After 4 years, we're at $13,010. So after 4 years, so if you were going to a 4-year school, this loan would be $13,010 exactly. So our answer for that is that it's going to take 4 years for the loan to become at least $13,000. So our last question here, a parent gave you 200 milligrams of ibuprofen for a headache. That's the typical amount of ibuprofen that you can find just like at the store. Each hour, the ibuprofen in the body diminishes by 9%. How long will it take to have less than half the ibuprofen left in the body? So same thing, we have to decide if this is growth or decay. It says each hour the ibuprofen in the body diminishes, so the value of it is going down. So that's how I know that this is decay. So my equation, almost the exact same, just instead of 1 plus the rate, it's 1 minus our rate. So our starting value, how much ibuprofen is starting in the body, that's 200 milligrams. And then our rate, it says it diminishes by 9%. Make that into a decimal, 0.09. And now we can plug it in. So I have y equals, A is 200 times 1 minus 0.09, all of that to the t. And just like before, you can simplify what's in the parentheses if you want, but it is not required. Let's see, 1 minus 0.09 is 0.91, all of that to the t. So we're trying to find when there's less than half of the ibuprofen left. So if we started with 200 milligrams, then half of that would be 100 milligrams. So I'm trying to find when this is right around 100 milligrams. It says less than half, so either exactly 100 or less than 100 is what we're looking for. So y equals, clear it out. So we have 100, and then our equation 200 times 0.91, all of that raised to our value of x. And let's look at the table. So after 0 hours, right at the start, we have 200 milligrams. After 1 hour, 182 milligrams. After 2, 165.62 milligrams. So let's see. It looks like after 7 hours, we have 103.35 milligrams. And then after 8 hours is when we're less than 100. So after 8 hours, there is 94.051 milligrams of ibuprofen. All right, so that is it for these types of questions. If you want to see how you can change how the table is set up on your calculator, keep watching. There was some questions on this last time. So right above this window button here in blue, it says table set. So this is the button next to y equals. In blue, it says table set. So I'm going to hit second and then table set. And basically, you can change how your table is set up. So if you want it to start at 0, like when x is 0, then you would click that. And then this delta sign is change. We used it with slope, like change in y over change in x. So this just means how is the table changing. I have it set to 1, which means it's going up by 1 every time. So our table goes 0, 1, 2, 3, 4. But if you wanted to make it a decimal and have it maybe go up every 0.5, you could do that as well. So now if I look at my table, that's a graph. I got to let it graph, I think. You can see that my x values go up by 0.5 every time. So it just gives you something maybe a little bit more precise. I don't really know when you would use this, but it's helpful to know. Also, sometimes if you are on one of the school calculators, someone sometimes scrolls it down to something insane and your table's in like the 100s and you want to quickly get it back to 0 instead of spending all the time clicking it back to 0. A way to do that is just go to the table set again. So notice I'm on 66.5 right now. If I click second table set, it's at 61.5 because that's what was at the top. I can just turn it back to 0 and then hit second table and it'll bring my cursor back to 0. So just a quick way to get back to the top of the graph or top of the table if you got stuck at a really large number accidentally. Same, it changes the negatives too. So if you have it as 0.5, then it will also go negative 0.5, negative 1, negative 1.5, and so on. I just like it to go up by ones typically, though. So just a fun little thing you can do with your table if you are curious.